In a modern industrial control system, it's a pretty common occurrence for the input of one PLC to drive the output of another. It doesn't happen by magic, it's called PLC to PLC communication, and it's the basic building block of a distributed control system. And all that's required to achieve this is a power supply to the PLC and an Ethernet cable. Depending on the manufacturer of the PLC, the communication could come in many forms: Profinet, EtherCAT, Ethernet IP, Modbus TCP, CC-Link, the list goes on and on. PLC to PLC communication isn't anything new. 15 years ago, that communication would have been over a serial link, such as RS485, RS232, or RS422. And let me just say, those old methods of communication, there's nothing wrong with them. They still work perfectly fine, but they were slower and more difficult to set up than the modern methods. Communication between PLCs doesn't just stop at inputs and outputs. They can share basically any data between them, such as whether the process is in automatic or manual mode, the volume of a tank, the current state of a motor, whether it's running forwards, running in reverse, whether it's stopped, or maybe even some alarms and trips from PLC 1 so that PLC 2 can take further action. Manufacturers like Mitsubishi have made it easy to do PLC communications, and that's because we live in a digital age where information is king.